It's always tricky to talk after lunch, right? So hopefully I won't get you guys tired here or exhausted. A brief introduction to who I am. In UL, I'm our technology leader for any type of cybersecurity services that we would develop to support our clients in different industries. And one of the things we've been challenged in looking at, and in general, over the last 10 or 15 years, especially in this industry, is how do you develop standards and specifications to help guide what could be considered best practices, with the ultimate goal and objective is you want to be able to measure the security posture and the security hygiene of systems so you can evaluate the risks that are appropriated to those systems. And then based on that evaluation, you spend money and you spend resources into the risks that you'd be willing to accept and the risks you don't want to accept. And just like Andre mentioned, there's different ways for that, but at the ultimate goal is really you want to end up with some level or a modicum of trust that you have within your system. So you can say, I have the trust, I have the belief that this is where the system is factored around security, and then I can move forward and make decisions based on that. So how do you measure security? Well, you can do it actually 5 different ways. You can look at, if we look at this chart here, let's start at the top left. Yeah, top left for you guys. Component security. For anything, you start looking at the supply chain. You start looking at different components and devices and systems as they plug into each other and assess those devices and components for what would be basic premise for security. And let's face it, I think even in the IIoT space, a lot of the basic tenets and concepts that we have today are fairly evident. They've been around for quite some time. There may be some new technologies, but there's nothing here that is, except maybe with some blockchain type of newer technology. And even with that, it's still around the root of trust and how you drive that authentication. So it's same technology concept. So you look at component security as being one of the main elements, actually trying to assess and evaluate where that component is. And then you start going around the circle. You start looking at your suppliers. Who's installing? Who's supporting it? Do they have those capabilities? You start looking at the site and the implementation. How is that configured? How is there a vendor that's managing that site? And then finally, you look at the system overall. And when you look at it in a situation like this, you realize now that you could potentially have in an IIoT space that now where your closed or semi-closed OT network is now having some visibility to outside, that you could have possibly different ways of measuring that security. There's hundreds of standards out there around security, and there are more and more that are coming around within the IIoT space. And you look at the graph on the left. I sat in an exercise maybe 4 or 5 years ago. We had a bunch of federal agencies from the US government, and we were trying to figure out, and we ended up with this chart actually. We were trying to figure out how can you drive cybersecurity throughout the industry and what are the pain points. And so the obvious pain point normally is cost. Manufacturers would definitely say, I used to be a manufacturer, that cost is a big concern. Dale actually was asking me this question just before we came up here on the panel. You also want to be able to have a quick turnaround on that, on what you're looking at. And so you don't want to have, product cycles nowadays are in the 9 months, 10 months, 12 months, but the longevity of installed systems are significant. So you want to be able to balance that out. You want to make sure that when you look at standards around IIoT, they're not rigid. That means they're not prescriptive, but they're aligned with a risk-based methodology that allows whoever is looking at it to make a good assessment of what the security risks are. You want to look at one of the things that we sort of identified on the left-hand side is a focus that has been primarily, if we're looking at industrial control systems, that's all you're looking at. If you're looking at IT systems, that's all you're looking at. And in industrial control systems, you can start even breaking that down. If you're looking at historians and the way how they're logging data, that's all you're focusing on. And so one of the things that we wanted to consider as we were in this group is, how can you have this portable? How can you have it move around to different industries? And the primary reason behind that is, how many people here consider themselves cybersecurity experts in the industrial space? How many of you started off doing that? So what typically we see happening is cybersecurity professionals are going to move around. We have a dearth of talent out there, a dearth of jobs. So we need to hire more people. So if you build these models that are so specific for specific industries and specific segments within those industries, you will find that you could have a potential lack of talent, because it's only 5 or 6 or 7% of the population that can support that in that industry. One of the things that we really found, which was really interesting, was building up a concept of a bill of materials. Everyone here who's worked for a manufacturer or has been a part of a manufacturing process knows that a bill of materials is a long list of hardware components. Sometimes it contains the software components. Well, the majority of security events that happen, and I'm not going to get into the debate about an event and incident. I think there was some discussion on that this morning, and both panels actually twisted and turned the terminology. But you want to look at the preponderance of security incidents that happen globally, and where do they happen mostly? They happen in software. So they happen in whatever source code is written and wherever it's residing, whether it's on a firmware within an embedded device, whether it's in a cloud system, whether it's in a mobile app, whether it's in some sort of software residing on servers and the like. And so we do a great job today, and we've been doing it for the last 50, 60 years, on building up a bill of materials of where is all of your hardware components coming from. But we don't do that today for software. And software is becoming the biggest risk. So one of the things we looked at is, if you look at this diagram on the right-hand side, your software can be sourced from multiple locations. Obviously, it can be developed internally. You can get it open source. You can purchase it from a commercial vendor. That commercial vendor now has that same supply chain source. And then the fourth and most, the least obvious one is it can be searched for on the web. I'm a software developer in a former lifetime. When I wrote software, we didn't have an expansive web. So you wanted to learn something, you had to buy a book and try it out. Nowadays, if you want to know how to connect to a particular IoT communication protocol, you just Google it, or Bing it, or search it, internet search it. It's not showing any preference here. So here you have all these sources of elements that could potentially drive improper security implementations within products, devices, and systems, but organizations are not tracking it today. And so as a vendor, or even someone procuring equipment from a vendor, you may ask for a bill of materials with multiple different suppliers, but do you ask for the same with software? And so those were some of the elements that we came out with and identified as really core tenets that are needed to sort of evaluate and find a good level of assurance of security within devices, systems, and components. And so I wanted to point out here a picture of a standards roadmap that we started developing, specifically around some of these elements. The leftmost column, the series of standards are UL 2900. They've been published for a couple of years now, and they're going through multiple iterations. We encourage everyone to participate. It's a public forum, just like every other standards development forum. But the first column really looked at the core tenets of how to look at that software bill of materials and what would be the challenges within security. Now, does it matter if that software is written for a PLC as it is for an infusion pump, or if it's written for a lighting control system? No, because it's the same security mechanisms that can cause security incidents. The constraints of it is like what Sid said, the use cases on the use of that. And so those use cases are in the second column, how you can define those requirements and add to them so you complement the first column with the second column to sort of define nuances that are applicable for those use cases. But obviously, the process and organization, as Sid mentioned, is the third column. And that third column there allows you to now look at outside of a product and evaluating and assessing a product, how can you do the same for an organization and a system? So what Andre mentioned was trust and confidence. You can look at something like this now, and you can actually get an assurance of a product, device, component, system, who designed it, how they built it, by actually testing it and evaluating it. And that's those first two columns. And then in the third column, you can do the same by assessing the organization. So what does that mean? Bare bones, what does our IIoT standards need to have in them? And this was sort of some of the things that we captured that we recognized should be some of the foundational elements that are there. Software composition analysis, that's that bill of materials. What's in your software? Where is it from? And what's the flaws and vulnerabilities that are out there? Fuzzing and code analysis are techniques to assess and evaluate that software and try to find weaknesses in it. Typical security controls that you talk about, access and authentication, remote communications, cryptography. But really wrapped around that risk assessment process and using a risk management technique to do that. And that's what will really drive IIoT standards today, if you're looking at it from a security assurance perspective. And that risk management piece allows, in that assurance perspective, to weigh those risks. Risks are for us, when you look at security standards, especially in the IIoT space, you look at three main bubbles. So you have the bubble on threats, the bad guy, the bad actors. A guy like someone sitting in a basement, or a guy who's sitting in some country there looking to do something nefarious. The second bubble that intersects that bubble is the weaknesses, the vulnerabilities that can be found in a device or a component that is deployed at a particular site or location. But the third most important bubble that intersects those three of them, and then they all come together, is the opportunity. Why should you go after it? Joel Langel today was giving a good description of that. He's like, people tend to focus only on the vulnerabilities and weaknesses, when what you have to really focus on is the risk of that opportunity. Because the bad guy has to look for an open door. But then why go through the door unless there's something really good on the other side? And so that usually is where risk management around IIoT security standards come into play. Because would you invest X amount of dollars if you were building an IIoT lamp that sits on a nightstand, as opposed to something that might be controlling your health, controlling a human, or controlling factory automation? So you stagger it and you base the risk, you base the techniques that you use and the cost that's involved based on the risk that's assumed there. And so the premise behind most IIoT security standards and the value that you see would have some of these core tenets, and some of them do today. We talked a little bit about them, and Andre talked about some of them. And so in the UL 2900 series of standards, this is what we kind of incorporated. I think what's really, really important is that box right outside. So the structured penetration testing, well, what does that mean? So it means you gotta hack the crap out of it. But you can't hack the crap out of it if it's a standard, right? Because you have to give some guidelines. You have to say what that means, because then it means if it's Doug out there, who I know is very competent, he can hack the crap out of something. But if it's someone else who's coming in, a junior employee, they may not be able to deliver that level of quality. So what's one of the most important things with standards, whether they're security or not? It has to be repeatable and reproducible. You have to be able to take that and apply it, whether you're in ISKI, in ISA Secure, whether you're at a national lab in Japan or anywhere else, and it has to be applied uniformly across the board. So putting in requirements of what you do when you perform all that product assessment and risk management to eventually provide a mechanism to pen test the crap out of it. And that's the umbrella of everything from an IIoT security. Really focusing on what I was talking about is security assurance. There's security design specifications, they won't need that. There's security specifications meant for asset owners, for procurement, they won't need that. But if you're offering up security assurance and the validation of whether a product, system, or component is Could never say the word secure, because nothing is, right? But if you're offering up some modicum of evaluation of the level of assurance there, then it has to be encapsulated around some criteria of being a bad guy and trying to break into it. That's the whole premise, I believe, for IIoT security solutions. And we did an exhaustive examination over this for the last 4 or 5 years, and I think building a foundation around those core tenets and core elements is what's really needed. Thank you.